So, first, welcome and thank you to be here for this presentation about JOOQ. We'll talk about SQL, JOOQ itself, of course, and my favorite database behind. So yeah, there's a lot of things in this presentation. And I want to thank you also to be here because we'll talk about SQL, and SQL is usually not the trendy subject, but seeing so many people, it's really cool. So first, because this presentation is very personal, it's my own story in these slides, I will start with my introduction. It's not something I usually do. I'm Kevin, Google developer expert on Google Cloud and Kotlin, so backend and operation, Gitlab Hero, and open source contributor, and I'm working at Gradle. Gradle, you all know Gradle, it's the famous build tool, an amazing piece of software, but I'm not working on that part. I'm working on something else. At Gradle, we try to help people to be happier, and for that, we provide them some tooling to help to get things done faster. We believe the developer productivity engineering is something like DevOps and other trend in our industry, and we invest a lot of time for that. And one of the amazing tool I'm working on is Gradle Enterprise. We are able to get a lot of information from your build tool using Gradle, Bazel, Maven, and it's very wonderful. You can do some test distribution, some caching things. Yeah, it's an amazing tool, and it's working with JOOQ and SQL inside. So yeah, I really like that, and all the things I will share with you today is coming from expertise on this part. So first, it's the place where I've done my scholarship. It's my office. It was my office up there, and it was in the south of France. And there I discovered SQL during university. And for me, as a student, SQL was about Venn diagram and strange syntax everywhere with all uppercase. I don't know why, it was the system at that moment, and all the information. And we try to solve every problem with the same pattern every time with only one query. So yeah, it was strange with a lot of query inside query. For me, in the same time, I was learning Java, C, C++. It was strange, and I missed the point at the SQL, and the database for me was more a data store. I put everything in it. A huge hash map was the same thing, and yeah, it was not the beginning of the love story I currently have with SQL. But in the same time, I started a pet project about podcasts, and I started with Java 6. And during the migration, currently it's running on Java 17, I've migrated to Java 8 and discovered some new pattern of for writing code. On the left side, you have the imperative way of doing things. On the right side, you have the same thing, exactly the same, but declarative with a new API. And you see, I've colored the concern of this example. It's messy on the left and really right on the right. And it's very simpler to understand things with this pattern. If I do an analogy with something of our real world, it's like if I want an iced tea, I can get the list of ingredients, get the recipe, and do it by myself, or I can just ask for it. And because I'm kind, I can say please at the end. And for me, it was really an epiphany to understand that this declarative stuff is way more powerful than imperative stuff. And it's the same thing in the cloud. With Kubernetes, you have exactly the same pattern. This is a YAML manifest. You declare what you want. In this case, it's just an Nginx server deployed 3 times by the system. You don't say how to deploy that. You just ask for it, and that's it. So 10 years later, I just understood SQL is just something declarative. And all the concepts I like in Java 8 and version after is just named differently in SQL. Table is a stream of tuples, select is a map, and everything. So yeah, I just need to update my brain on that and get the right naming for the right thing, and then use SQL for everything I want. And in the Java world, SQL It's something from the beginning. But how do we start with SQL? So first solution, it was JDBC. So here you have an example, a JDBC example. I just want to get some data from the database. You see it's, first of all, just plain string, so really hard to manage. If you want to add additional condition, for example, it's positional parameters. So if you change positional parameters, you have to modify everything. And at the end, the don't repeat yourself stuff is not done because title and ID are repeated. So yeah, it's something working on Java 17 and even 19, but it's very hard to read, hard to get, and yeah, it's because JDBC is really old. In fact, JDBC was released in Java 1.1, the same year as The Lost World, the second Jurassic Park, so now 20 years after that, 25 years almost, we have 6 and maybe 3 Jurassic Park film added. But yeah, it's the most important API from the beginning. It was one of the reasons the Java ecosystem was so powerful at the beginning with this JDBC stuff. And even the API was supported by more than just database access. It was used by everything providing data, not only database. And it's what you've seen in the previous slide, it's very low level. It was not meant to be used by end users every time. It's just something to be used by framework above this layer. So this is because that we are calling this the JDBC driver. It's the last layer between your code and the application. And after that, EGB2 appears. So yeah, it was something. Luckily for me, I've never used EGB2 in production. I tried that for this presentation. It was a bit hard to do and implement this, trying to find documentation. Today it's really complex. But still, we see some concept, not something familiar with the new framework. We'll see that after. But you have the object podcast and the podcast repository extending something from the AGB part. And then you have to configure everything through XML. It was the way at this time. And if you dig inside this XML, you see it in the middle. The query seems to be SQL, but in fact, it's not SQL. It's AGBQL again. So it's not SQL. And it's something at this moment, we already thought it was a good idea to improve SQL and provide something above it instead of doing plain SQL all along. So yeah, it was something with AGBQL language, AGB application server, JDBC, just sometimes to do a CRUD application. It was really painful. And if you've managed that in production, I want to applaud you. It was really a nightmare. But from this world, AGB disappeared, but object relational mapping, ORM, stayed, and many implementation, Hibernate, Eclipse Link, OpenGPA, rise from that. So it was the good part of AGB remaining after this. So ORM, JDBC, and database. And after that, because we like standard in the Java ecosystem, you all know this is KCD about standard. For once, it was a success in the Java part. We don't have a new implementation. It's just the idea of communication with the database and annotation stuff everywhere. So GPA was something, and it was added to the system. Here you see it's a very standard entity, some annotation, getters, setters, and everything. You really need, if you use that, you really need to be careful about the equals and hash code because it's used by all the implementation to do the cache optimization stuff, to duplicate and deduplicate things. So yeah, it's very important. But like you see, it's something with the object first, object to database. Even if Hibernate and every other ORM said you don't have to generate your database from your model, I can't say how many people I've worked with, they generate from object the whole schema in the database. It's something possible, but it's not recommended because you are from an object model to a database model. It's maybe not compatible. So yeah, this is the way in GPA, but even with that and no recommendation on this part, it's something usually done. But here it's to store data if we want to fetch some data. Here we have two examples. The find all thing, here it's using query, but it's not SQL again, it's GPQL. Okay, it's a specific syntax, I don't see the select, it's just from, okay. But it's not type safe, again. It's something where you have to provide the return type for the projection at system level. So if you change something on your database in the same time, it can break everything, and you will see that only at runtime. Another API available in this GPA part, it's criteria query. It's again, it's not, it looks like SQL, but it's not. You have to provide types at the beginning, and you see the from is from a type, and we can think the type is used from the entity annotation, but I have to use the return from the from inside the select, and the select as the aware. So, sorry, I know SQL, and this is SQL-ish, but not SQL for me. And you still have something to, the don't repeat yourself is not here again, because you have to repeat something from the annotation part in this specific element for ID, for example. So again, if you change the ID on the database, it will crash at runtime. And I don't want to crash at runtime. It's too costly. So GPQL, GPA, GDBC, so many layers. And with two entities, it's the beginning of the end for me. The many to one, one to many for every developer playing with GPA, it's an endless problem to set this, and on Stack Overflow there's hundreds of questions about that. And for me, it's the annotation hell. Even the previous one, previous set of annotation was something. Here it's more than that, because with just this annotation, you can break everything in an application. First, I like to test everything I wrote, because if it's something from me, I don't want to test the framework, but if a developer chooses to change the fetch type here, fetch type lazy to fetch type eager, maybe the application will get the whole database into memory just because of one annotation change. So I want to test that, and it's really hard. It triggers side effects. So if you like functional programming, you know side effect is something you want to avoid. So calling a getter, it's just a getter at the end. I don't want something else. And in fact, it will generate something at the database level. And the resulting query from this getter, it's something you don't control. So maybe from version to version, the implementation will change, and it will get more data or less data, and it can be harder to reproduce that on testing environment. So yeah, for me, it's really hard to manage. And if you want to improve that, of course, we already want to improve that. In GPA 2.1, we have this named entity graph. This thing is just to replace the word join. It's just an optimization to improve the system to get only what you want following a specific request. So here it's 4 letters or this name entity graph with multiple things. So for me, it's just why? Why do we need to do so much thing just to get data from a database with a language already available to everyone? And there is an hidden message in this slide, if you're able to get it. Thank you. DRM, for me, there is a problem with them, and we try to fix them, fix our usage of ORM instead of fixing the original problem to get data. And ORM has some neat features, like, okay, I use an ORM, I can change the ORM. Okay, do you change the ORM often? I don't, and I don't use ORM anymore, but in the past, okay, I used one, and the whole project was running Hibernate from the beginning to the end. That's it. It's not a problem. And you can change the database. Yes, it's a subject, but it's not for free. You still need to migrate the data. You need to migrate some types which are not available from the previous database to the new one. So it's a feature, but still you have something to do in between, and it's in the ORM level. So still something. And we can go deeper. Spring Data GPA, Micronaut Data, and Quarkus with Panache are really cool projects. They provide you some neat implementation or things around an interface. So it looks like a GB 20 years ago. And following convention, you are able to get something just by writing Java code. So on the right, you have the SQL query. On the left, the code to generate this query. And the type, the from, are coming from the generics parts. The conditions are extracted from the name of the method and the parameters. And of course, the select is the resulting element, so the return type. I don't know for you, but for me, I prefer to maintain the part on the right. It's simpler, it's shorter than the part on the left. Okay, it's magical, but I don't want any magic. It can fail at runtime. In some framework, it's done at compile time, which is good, but still, there is less thing to maintain on the right than on the left. So many layers with many things. And for this presentation, I've done some investigation on that, and I found this important and really cool question on Stack Overflow. It's 30 years ago now, so 23, yeah, it was already a subject at that time. What ORM do you prefer? And the answer, the selected one, was just drop ORM 30 years ago. We are still using them today, so there is some advantage to them, but still, it's something if you want to do advanced stuff, yeah, maybe they are not the solution. So I want to move out from this solution and bring back SQL in the discussion. And for that, we have to remove all these extra layers. We'll keep only the JDBC stuff and add JOOQ for that. And by the way, JOOQ is able to use R2DBC, so JDBC or the other one, it's possible. So with JOOQ is just here to simplify your life. It's just a DSL in Java for SQL. So if we get this query, very simple one, I just fetch 3 fields from one table and do some order by. This is a SQL query. This is the version with JOOQ. It's some Java code here. There is not so much difference between them. It's just some parentheses and this field stuff in the middle. If I do that in the real code example, find all, it's again the same thing as the previous GPQL example. I create the fields, so ID, title, and URL. I do the casting thing at the end and do the select with them. And at the end, I fetch the data and map it to the object podcast, and I have the object at the end. Okay, really cool. But so it means if you know SQL, you know JOOQ, because the API is the same. It's just finding where you put a point and parentheses, but nothing more than that. But this example is not type safe. You've just seen there is some .cast thing to provide the type information. And it's not something I want to do because it can fail again at runtime. It's because JOOQ is made to be database first. And for me, it's the only good solution. You have your database, you can extract some information from it to generate your code. And it's exactly the meaning of this JOOQ generator. It's something you can use to connect to the database, extract the schema of your database, and generate some Java class. And when I say Java class, it's real Java class. You can read the code. It's not some bytecode generated and not available and annoying during debugging session. It's plain old Java code. Small tip on that, if you want to do some production stuff, use Liquidbase or Flyway or any database versioning tool. It's very powerful and JOOQ is able to connect to it. So yeah, just use one of them. This generator is just a simple Java application, so you can launch that through a Java CLI. It's compatible with Ant, Maven, and Gradle, of course. And it can generate code for Java 7+, Scala, or Kotlin. So if you want your code to be generated code to be in Kotlin, it's up to you. And with this generated code, the previous query, this is the SQL one, and this is the JOOQ one. Again, just some parentheses all over the place, but still really the core thing of the SQL part. Here you have this example in real code. In fact, it means here I have access to this podcast object. This is a static variable imported from the generated class, and I have access to the fields on my database. So every column is a field on the object, and I can use that to create my object. The API of JOOQ is massive. I think I've discovered things every day on it. Here, it's a simple example. If you fetch something and this something does not exist, you can map to an optional. So it means you'll get an optional empty if it's not available in the database, or the object mapped to this new podcast thing in the Java code. And is this really type safe? In fact, I think, it's my point of view on that, and not working for JOOQ, I think this solution and this product is the most advanced project in the JVM using generics. There is generics all over the place in the JOOQ generated code to be sure the type is the same and you are able to do only what you need and what you are able to do at the database level. Here, you see, we have this UID stuff. It's part of the table field generated, the generics part. And with that, JOOQ is able to generate method with this specific element. And so I won't use IntelliJ just for this example. But here, if I want to implement a file one, I'll get this equal method on podcast.id. Equal is available for UID type, but not for string, of course. So it means error at compile time. And it's always better to have this error as soon as possible. And with the ORM, it's always a problem. With JOOQ, what is the generated query? I want to know what it's generated from JOOQ. So this example is a simple query. Yeah, this is the prepare statement. So very close to what you already wrote with JOOQ. And we always want the query parameters. So yeah, you have access to them. And this is the real query sent to the system by JOOQ. And if you are in development session or testing session especially, and you want to have access to that for debug, or you want to improve your test, you can. If you have this kind of library in your system and you set JOOQ at the debug level, you're able to get that in the log. So for me, it's powerful, and working without that, for me, it's a nightmare now. I have access to the prepare statement, the query, and even a table, an ASCII table with all the results inside the log. So yeah, it's very cool to get that. You don't need to open your favorite database IDE to run the query by yourself. It's all done by JOOQ directly for you. And this example with one object is a bit simple, but with two tables. It's SQL again, so we can just write what we want, and here it's the simplest solution. So here, one advantage of that, if I want a join between two objects, I can select just what I want. It's what we call the projection. Here I get only the ID, the title, and the URL of the podcast, and the cover associated information. I won't load the whole entity just for 3 fields. So it's better for performance. And here I have the podcast inner join cover, and I do the join by myself. And this join is type safe because JOOQ knows the cover ID is the same type as the cover.id. So yeah, it's built in and it's available for you. And the order by at the end and some limit stuff. Really simple. And this is a really simple example to get what you want from JOOQ, but you can also map to any type you want. With entity and GPA, it's something you have to stick to a specific entity or do some specific projection, which is a bit harder than the usual case. Here, with JOOQ, you're not tied to a specific entity. So here I've created a podcast with cover with an inner object to create this specific object. So it's SQL all over the place. So if you know SQL, you will learn with JOOQ, it will be simpler for you. And for people, it's sometimes boring. All the magic stuff from all the framework available can be really fancy, but here, for me, I like to manage my data with boring stuff, because if I lost my code, data is the most important part. I lost my code, it's not a problem. I lost my data, or there is something magical, after an upgrade, all my database is wiped. I don't know why, because of this lazy eager stuff, or cascading delete maybe. I've done that. I've seen that in production lately. So yeah, I don't want to mess with my data, and having small layer just between my code and the database, it's better. So yes, it's boring, and for me, it has to be boring. But it can be sexy too, because JOOQ has a lot of information about your schema. So it knows the foreign key association at many levels. So you can have this kind of thing here. Instead of using directly cover.url, I'm able to use podcast.cover.url, and JOOQ will do here. In this case, I just defined the from, and JOOQ will do and infer the join and the foreign key link between your tables. So it's not all the information is available in the schema part, so it's something possible with JOOQ. And the other case, MN relationship. It's a place where ORM are really good, because if you have this kind of thing, so a podcast, tags, a podcast can have multiple tags, and tags can be associated to multiple podcasts. It's something hard to manage, because the resulting of any query will be that one podcast on the left, one tag on the right, and you need to do something at code level to do this deduplication thing. So with JOOQ, we have a specific element called multiset. We can do a whole presentation just about this feature, so I will be quick on that one. It's a multiset. You can use an inner query, and this query is linked to the object. So the podcast ID you see here is the same as the podcast ID here, and I trigger something to get the tag list. And in this example, you see I'm using records, so it's compatible with Java 17, of course. And I'm doing the mapping at the end. You see that here. And this mapping is reflection-free. So it's compatible with record and able to be done without any reflection stuff. So it means compatible with GraalVM, fast, and it can be improved at any level. And I don't have any mapping stuff. It's just values from my database set into my object. Very simple again. And I forgot one slide. The generated query is that, in fact, JOOQ leverages some part of your database system. So here it's with PG, Postgres. It's using the JSON part to generate some subquery for you. And then the result of this query is that on the left, your podcast, on the right, the JSON list of the tags associated to it. One question usually it's when I have a database which not supports some standard syntax. For example, the first one, it was about the limit. The limit part here is something where which is supported by most of the database outside, Postgres, MySQL, MariaDB, but it's not supported in SQL Server, for example. JOOQ will adapt this thing to use top 3 instead of limit 3. And if you are using an old version of Oracle from 2 or 3 years ago, it will generate that for you. So I don't want to be the one who writes this kind of thing just to do some kind of limit. JOOQ will do that for you. And JOOQ can do, so this, it provides standard features, standard SQL to your application, but it can do the other thing too. It can provide some features, not part of the standard thing, but for your database. In fact, I don't really like the insert into stuff. Again, it's positional parameter everywhere. So if I want to change the order for any reason, I need to change every values line. So this query is just in Postgres, is the resulting query is that, okay, standard one. And I can use a syntax provided by JOOQ and available in MariaDB, I think. It's some kind of, it's the update syntax for insert. So it's insert into a podcast, set the field and the value of this field on the, in the column. So it's simpler to read from my point of view. And it's available for you if you are using PG. It's not only available for MariaDB in this example. And the generated query is that at the end. So the same one. And it can emulate a lot of things for you and provide some non-standard features, even if your database doesn't follow the ANSI specification. For example, on duplicate key update, I've seen so many people doing a query just to check if something is available in the database. Okay, it's not available, I will do an insert, else I do an update. Here you can just use that on duplicate key update and you provide the information to be changed in case of update. And the same thing if you have some unique constraint on your database. And the generated one, it's interesting to see this kind of query at the end using advanced feature, but built in your database. So why do you need to do some extra round trips just because you, and with this kind of feature, you can just remove that and improve your application. So JOOQ is really here to be your best friend for SQL or every day. But sometimes people say, okay, but I just want to do a CRUD. And for a CRUD, I can use something else. It will be simpler. And my project is just a proof of concept. Yeah, you can, but it's not safe. And we all know a proof of concept ends in production at the end. So yeah, I don't want to mess with that. And I want something safe at the beginning of my project. But JOOQ provides some alternative for you. One alternative is active records. It's something used, by the way, by Quarkus. Quarkus with Spanish is using this kind of pattern, active records. In JOOQ, active records, it's just the representation of one line in your database. So one line of one table. Here it's the podcast table. I just load one line and I set the ID here, and then I refresh this ID. So at the end, the object is inflated and all the data is provided to everything. So in this case, it's not optimized. It's loading the whole line for you. And you can do what you want with that. And you have a lot of features associated to that. So it means you can update, delete, and do a lot of things just by accessing the line of this thing. And it's generated by the generator. So at the end, you can use that with the SQL part too. And all the methods available for you if you want to use this. And some people want something more on this part, some DAO. So DAO is something I called before repository. You can have that in JOOQ. You just in the generator, you set the flag data to true. And at the end, you have DAO to true, sorry. And you have this thing. It looks like GPA entity. And in fact, you can ask JOOQ to add this annotation entity all over the place. So JOOQ can generate things from your database and generate this entity stuff. So if you want to mix JOOQ and GPA stuff, it's possible. And you'll get this podcast DAO. And all the methods here are real methods. It's not something generated at runtime. It's done at compile time, and you are able to get the code from every method. So it's very powerful if you want to know what is the best solution to get data with this requirement. It's possible to just dig into the code. And then you add a bin annotation to this object, and you can use that as any other repository from any system available out there. So yeah, it's just simple as that. And if you use DAO, you'll get active records in the same way. So you have a lot of features built in for you if you want to do something simpler than huge SQL query. But for me, I love SQL, and people ask me a lot, why do you need to go so deep inside the system? It's because with SQL you can do anything. It's not just, we are doing a lot of things to get data from the database and provide them as JSON in the UI, but if you want to do more than that, you need the powerful thing SQL is. So for me, it's something really important, and I can do anything with it. So as an example, I would like to use the search engine of my podcast application, and we'll go inside in the implementation together. So here you see it's just some fields, really simple UI. The search part is done on the item description or item title. The tags, like you've seen before, is done not on item but on podcasts, so there is a link in between, and all the fields after are to filter on something and to do the sorting and the pagination. And this can be done at the global level or can be done at the podcast level. And because you are using SQL with JOOQ, it means you need to know and understand your model. And this is for me, my application is very small, 1, 2, 3, 4, 5 tables. But just for that, it's way better to understand the model than relying only on objects. And with that in mind, we'll create this part. So here, the UI, I have almost the same thing at the parameter level of my search method. And I will create first the condition. So instead of, like with JDBC doing string manipulation, I will use all the powerful JOOQ API. So if the query is empty, I will use a no condition. If it's not empty, I use this item title containing your case, and the same thing with or on the description. For tags, it's a bit harder because I need a link to another table. So I will stream all the tags ID provided from the UI and create a subquery for each element. And at the end, I will do this reduce stuff to do an end on every provided subquery. So it's a bit advanced, but it's a great example to do advanced stuff with JOOQ. And those are almost the same. If empty, no condition, or null, no condition. And if not, I provide the right condition. And because all conditions are end, I use with end, I do the end stuff on all those conditions. So at the end, I have one condition object, and I can use that everywhere. It's type safe, and everything is checked at the system level. Okay, now in my application, I know the system, and I know I won't be able to return more than 12 items in one page. It's something I know by design. And the problem with ORM, it's usually the link between tables are done first, because there is a from inner join multiple times. And after that, we do the filter stuff. So I don't want to do this join thing and then filter, because I will just consume CPU and RAM for nothing if I join then filter. So I will just here generate the query for the item part, and I know this one will result only at most 12, will provide at most 12 elements. So this is the first part of my query, so filtered items here. And then I will use that in another query, and I will join on this. And the complexity of that is at most 12 times the number of podcasts, the number of cover. So it's way less than the ORM version of that, with everything merged in the same way. So this is the first part. And you see, I'm using all the credential. It was not credential. All the condition is used there. So it's very simple to use. And I'm able to reuse this condition again with this total element thing, because I want to provide to the UI some extra information. Okay, you are on the page 4. There is a 10 page, and you are not on the last one. So it's usually something you want to provide for the UI. And here I'm able to use the same condition again. And the query done at the end, it's pretty massive, yes, and it can be more than that if you provide more tags, but it's only one query. It means everything will be done in one round trip at the database level. So it's very cool to have this kind of feature to get this query done by JOOQ, and everything is type safe. So if it compiles, at least at type level, it's okay. So for me, and because I like the functional programming pattern, input, output. The output is some SQL stuff. Input are the thing from the UI. So I just here to implement the transformation between the value in the UI and the SQL part. And I have access to all the SQL capabilities. And this is amazing. We are talking a lot about SQL, thinking about the version from 92. 92 is 30 years ago now. There is a lot of feature available in every database, and you can use them. So we don't need to, we can leverage them in every cases. Here, in this example, the common table expression. It's something from 99, and it's the part, it's this part. In fact, instead of doing a subquery in the from part or maybe on the where part, you can do something with this filter editing part. It's one query. You can do multiple common table expression like that, and you can even link object result between them. It's very useful and it's simpler to read. As an end user, I know the first part I have to read to understand the system is this part, and then I can use the result from the previous one. Sorry for the slide. So, and this is supported by almost every database. So use this kind of thing. Another example, just because I can, I've implemented in this application some statistics stuff. So statistics are done using the type of the podcast, the platform where I've downloaded the podcast, and the data, the number of podcasts downloaded, item downloaded, sorry, from at the specific time. And here, you see, it's not something related to my object model. There is nothing related. It's not, the result is not a podcast, an item, or a tag, or a cover. It's just something for the UI, for the business I want to address. And I can do that very easily. Podcast type, the date, and the count. Nothing more. And at the end, I have a tuple of 3 elements. I can name that because we don't have tuple in Java. But it's just that simple. There's nothing more to do to query something different than your original entity. And the SQL part, it's almost the same. No surprise here. It's just the implementation in PG. And the resulting stuff is that, so it was a chart before, here is just a table, but still it's the same thing provided from SQL directly to your application. During work with many developers, I've seen if they're able to get data from the system, they're able to construct things above this. So if I ask you to provide some aggregated value over the previous results, sometimes people do just that in memory. Because I have the data, I can just stream on it, I have the stream API in Java, and I can do this by myself. Okay, you can. Not because you can, you have to do that. The JVM is really powerful, but your SQL engine is maybe more powerful than JVM itself on this specific thing, because the SQL engine is made for that. So don't do that in memory, do that on the SQL part, and you can use a feature from 2003, this other feature. The other, so you see the query is almost the same. I will switch directly to the Java, to the SQL part, because the Java one is almost the same. Here I've just changed count to sum count star over, and there is some predicate in this other part. If you take a look in the implementation and how it's working behind the scene, it's like that. I select a partition, so the partition is the podcast type, so it's all RSS here. I order that with the date, so date on the day, not at the second level. And after that, I do the count. And the last line is row between and bounding preceding. So I'm the first line, I count, I do the sum until the beginning. So I'm the first one, so it's the same. And the current row to me. So, okay, 2, 2. If I do the same with the next line, row between, so it's the previous one and myself, you have the 5 at the end. And the next line, it's me, the previous line and the line before that. And again, you have the 6th result at the end. It's with that, it's the first partition, and the system will do the same thing for the next partition for you. So it's built into the system, and you're able to get data, advanced data, just for your use case. And if my database have a specific proprietary syntax not supported by JOOQ, I love PG. PG is the best database ever, and there is some feature in that like JSON and JSONB. You can use some advanced features to store JSON in your database. And here, you see, I have set, sorry, the slide is good. I set a specific field with the JSONB type, and I have a lot of operators to access this field with direct access to a parameter in this JSON to go through the JSON element. And here it's stored like that in database, and you can index things on this JSON. So if you want to improve the performance of the querying inside this column, it's possible. So you have all the feature provided by the JSON support directly to you. But it's not supported in JOOQ. So how do we implement that? In JOOQ, we have all the things to create our own operator and method. So here it's just a simple static method in my code, and I provide the JSON path here, or the ASCII implementation. It's up to you to define the code, the operator. So you have to read the documentation, of course, but still you have the ability to improve the system to support things not supported by default. And if you are using Kotlin like me, it's very cool because you can use the function extension function, sorry, to do that on an object. So podcast metadata dot pass, and I provide the YouTube channel ID. And the generated code from that is what we expected from it, is just using the original operator and the parameter expected from the database level. So very simple. And then you can leverage all the feature from the JSON side. So for me, I don't have any reason to use any NoSQL stuff because I have the powerful part of the SQL and the NoSQL at the same time with plain SQL stuff everywhere. So it's, yeah, there is no discussion about that. So this talk is and was about JOOQ, but JOOQ is all about SQL. So in fact, it's with JOOQ, for me, it's the best solution to learn SQL. So if you want to learn SQL, starting with JOOQ is not a problem because you will learn by using the auto-completion and all the documentation to get information about your system. So it's very pleasant and powerful for you to use this kind of thing. And why SQL is so important today? It's because SQL is declarative, and it was my discovery, a bit late, but still a discovery. The SQL code from '92 can run today on PG. It's not the best code ever because there is new features now, but it's still running because there is no implementation detail. It's just declarative. And we see that because now SQL is the data language. SQL is everywhere, in fact. Spanner, the database from Google, which almost breaks the CAP theorem, it provides a PostgreSQL interface. They released AlloyDB in June, I think. It's PG under steroids provided on Google Cloud for you. Okay, powerful. Yugabyte provide the same thing, but with multi-cloud capabilities. It's open source, so feel free to use it. It's really, really interesting. And it's supporting SQL. BigQuery, which is not a SQL system at the beginning, they choose to ditch the original syntax and use plain old SQL and C1 in BigQuery. Redis provides something to support SQL. It's still a kind of incubator thing, but it's something. Apache Drill, PrestoDB, they all provide some SQL interface to communicate with many databases. So SQL is everywhere. Even 2 years ago, DataGrid and JetBrains provided something at DataGrid level, so you can use SQL in DataGrid to ask something to MongoDB. And 1 month ago, MongoDB released something what they call new NoSQL. In fact, it's just SQL to access MongoDB data through SQL. So SQL, again, it's the data language. It's the simpler tool to access your data. So learn it, to discover it with JOOQ or not, but at the end, it's the powerful stuff ever for data access. So JOOQ is not compatible with everything I just introduced to you at system level, but still, it's not yet possible, but it's still a good solution to learn SQL and to improve your application instead of relying on some magical stuff. With JOOQ, you have better access to everything on your system. This is why I love JOOQ, and I've made this presentation today. If you want more, there is a really amazing book about JOOQ to discover this, so feel free to buy it on Amazon if you want. It's a very good one. Thank you, and if you have any question, I'm able to answer. I have, I think, 2 minutes. Thank you. And because if you want some Gradle swag, there is some shirts here, stickers, JOOQ and Gradle, and you can scan the QR code if you want. And do you have any question? Yes, one question.
Do you have any knowledge how it compares with Slick for Scala? It looks similar to me, but...
No, sorry, no, I don't have any. I just discovered the name with you, so no, I don't have any idea about it. Sorry. Yes. Yeah? If you want, yes.
Yeah, you were asking about, you were telling about reading the schema and then generating objects from that.
Yeah.
So is that done by actually accessing the database, or will it just parse all the flyway scripts and extract objects from that?
It's accessing the real database. So usually you can do that using a spawn database in a Docker environment. For example, you spawn one Docker container, you apply the flyway or liquid-based thing to it, and then generate the data from it. So it's usually how we do that in our case. But there is some solution to parse or use an intermediate H2 thing, but I don't recommend that. Yeah. Any other question? Yes?
What about eager loading, lazy loading, caching, which is typically in an ORM?
There is nothing for that. It's up to you. If you want to improve the system and provide some caching stuff, you can use whatever you want. EHCache, Infinispan. Yeah, it's possible, but it's up to you. So it's plug and play. There is nothing to prevent that, but it's not built in into the system. Yes, sorry. Javadocs, there is one, yeah. The Javadocs is really, you've seen the Java code generated from JOOQ. There is some Javadoc in it, and there is also Javadoc for everything. Lucas Eder, which the main maintainer of JOOQ, is really a madman about the Javadoc. So there is Javadoc about everything and why something is not possible in your database with link to the official documentation. Yeah. Yeah, you have generated Javadocs from the code, but this generated code, it's up to you to decide if this is something generated when you publish the application or if you commit it. So maybe you won't need even to read the code. It's up to you. And I think the time is out. So if you have any other question, I'm available today, and feel free. Good. Thank you again.